Good day, my viewers. I want to warmly welcome you once again to our YouTube channel, our mathematics channel, where recall that we have been talking about the revision of JSS mathematics work, which will naturally launch us into the SS curriculum. And we have been talking about numbers and numeration. We say after that, we could look at algebra, we'll look at geometry, we'll look at mensuration, we'll look at trigonometry, etc., etc. But while we're still on numbers and numeration, one of our viewers actually posed a question, which was, digressing a bit, if you like, into algebra. Even though I have reacted to that question in the comment section, I feel because I want to go through the nitty-gritty of whatever we are doing here, I feel there is need for us to do a video of the actual solution of that problem. We want to factorize the above quadratic expression. Look at this quadratic expression well. You actually have two variables. The highest power is 2. That makes it quadratic. So this expression is both quadratic in G as well as quadratic in H. But then if we consider it that we have a variable in G, we are going to keep every other thing here, including our H, constant. If we also say that the variable is H, it means our G will be constant. Let's solve this problem, considering that our variable here is G. That means our H is a constant. Recall the general form of quadratic equations where you have ax squared plus bx plus c always equal to 0. When we equate the quadratic expression to a value, once you introduce an equality sign, it becomes a quadratic equation. Otherwise, it will just be a quadratic expression like here. Okay, let us change our quadratic expression, the problem we have, into this form. We are quickly going to have 10g squared plus our b will now be g. Sorry, our b will not be g. Our b will actually be h because it is our g, like I said earlier, that is our variable. So let me have hg minus 3h squared. Here, the coefficient of the first term, coefficient. Let me write that, coefficient of the first term, that is A, is equal to 10. Coefficient of the second term, of course, will be H. Coefficient of the third term, if you like B, will be H. And if you like to C, will be equal to minus 3H squared. So once again, our A is 10. My B is H. My C is the whole of minus 3H squared. What am I going to do? When we want to factorize a quadratic expression, we naturally think of two factors. Two factors. First of all, these two factors, their sum will be able to give me the coefficient of the second term, which is H. That is, their sum will give me H. And their product, the product of these two factors, will also be the product of the coefficient of the first term and the last term. That is A times B, A times C, which in this case, my A, like I said earlier, is 10. My C is minus 3H squared. So A times C will be 10 times minus 3H squared, which is going to give me minus 30H squared. So that is the product of the coefficient of the first and last term. Remember too that the coefficient of the second term, like I said earlier, is h. So I'm quickly looking for two numbers whose sum will give me h and whose product will give me minus 30h squared. put in the form I put it before, two numbers whose sum will give me the coefficient of the second term and whose product will also be equal to the product of the coefficient of the first term and the coefficient of the last term, A times C. Let's think. What comes to my mind is minus 5h and 6h. These are my two factors. If I add these two factors, minus 5h, and adding them, of course, minus 5h plus 6h is going to give me h, which is the coefficient of the second term, so it meets that condition. What about if I multiply them? I'm going to have minus 5h multiplied by 6h, and that is also going to give me minus 5h times 6h. It comes out as minus 30h squared. So it also, these two factors have met the two conditions. So quickly, you are now going to see the beauty of our quadratic expression. Sorry, I have to clean up some things. So of course I go back to the original expression we are trying to factorize, which, if I remember very well, is 10g squared plus h minus 3h squared. Because I have gotten those two factors, minus 5h and 6h, I'm going to rewrite h in terms of those two factors I have. I can still write h as 6h minus 5h. Of course, 6h minus 5h will give me h. So I write in that form to have 10, hold on please, 10g squared minus 5h plus 6h minus 3h squared. Something is common between, sorry, this is actually, remember this is GH or HG, is the same thing. HG or GH is the same thing. Remember that this is minus 5G HG plus 6 HG, etc., etc. So something is common, like I said earlier. This will now imply what is common? 5G is common into what will remain here. I have 2G minus H plus, this is 6GH minus 3H squared. Something is common, and that should be 3H being common into what will remain here. We have 2G, because 3H times 2G will come back as a 6HG, if you like. This is 3H, so what is remaining here is just H, because 3H times H times minus H will give me minus 3H squared. So this is the new factors I have. And remember that, recall that if I have 2x plus 3x, I can quickly factorize this as x into 2 plus 3, if you like. This is just in the passing. So if I apply this here, apply what I've done, apply it here, you can see that 2g minus h is common. You have 2g minus h here, you have 2g minus h here, which will imply I can now have 5g plus 3h, of course, into 2g minus h. That is the factorization of the quadratic expression. And don't forget what I told you earlier. You may also want to rewrite this. This is like a homework for our viewers. You may want to rewrite the original expression as minus 3x squared plus hg plus 10g squared. And consider this expression to be quadratic in terms of h. That is where h is the variable. Where this, of course, the whole of this will even be a constant. This is the second term. Here, because x is my variable, that makes g the quotient of the second term. If you also make that consideration, you are going to arrive at the same answer. You can try that at your own and come back and tell me something good in the comment section. Thank you very much for the little digression which we did in today's video, trying to factorize quadratic expressions. In our next video, remember, we'll go back to solve more standard questions, JAM and WIRE questions on numbers and numeration. If you have really enjoyed today's video, kindly don't forget to share our video, also comment freely, and also subscribe to our YouTube channel. That will be your way of saying thank you for what we are actually doing. Thank you so much, and see you in our next video.